Very good morning to all of you. So today we are going to understand the positive and the negative clipper. This is the important application of the operational amplifier. So starting with the definition that the clipper is going to clip some portion of the input signal. In our case, we will be taking a sinusoidal signal. So basically, the positive clipper is going to clip the positive portion of the input signal, and similarly, the negative clipper is going to clip the negative portion of the input signal. So to understand the concept of the positive clipper, we'll try to discuss the circuit diagram. So you can see here that this is the operational amplifier, and as you can see that it has got two inputs, the inverting input and the non-inverting input. Now to this non-inverting input, we will try to apply, or you can connect the input signal, and these are the biasing voltages. Now why this biasing voltage is required? This is a dual, this IC will require a dual power supply, and as you know that the first stage of the operational amplifier is dual input balanced output differential amplifier. So basically, to bias your transistor, you will be requiring two voltages. That is, you can say this has the minus 15 volt or the plus 15 volt. So this one is the operational amplifier. These are the biasing voltages. Now coming here, there is a diode. Now you can see that the immediate output, to the immediate output we have connected a diode, and this is connected in the reverse fashion, and after that the output is taken. Now you can see that the entire voltage is fed back to the input side. And what is the voltage? You can see that we have taken the voltage is some fraction of the VCC. Fine, you can see here, right, we are having the VCC. This one is the VCC, that is plus VCC, and there is a tapping, and there is a tapping. This one is R2. So we have taken some portion of the supply voltage. So as you can see that VCC is a fixed voltage. So this voltage, this V reference is also a fixed voltage. This V reference is also a fixed voltage. So this voltage will be smaller as compared to the VCC. So now coming to the clipper side, so you can see here that this voltage will be coming across your input side. Just you can see this voltage, that V reference which we have taken from the VCC is coming to the input side. So now you have got two voltages. The first voltage will be a sine voltage. This is a sine voltage, and this voltage is alternating voltage. The value is changing with respect to time, and this one is the fixed voltage because it is derived from the fixed the biasing voltage. So now you can just play with the waveforms. So first we will draw the input voltage. This is the input voltage which we are applying. So now this one is a VI, as you have taken the sine voltage. So right, this is the sine voltage. Okay, so to differentiate the things, just a minute, I will take a different color. So now this is the V reference because you are going to have the positive value of the VCC. So that will be V reference. You can see, okay. So now we have plotted with this. So what is going to happen now? We'll try to understand the concept of the operational amplifier. Now basically initially the diode is in the no bias condition. We have not applied any voltage to the diode. Now the diode is an uncontrolled switch. If you apply a positive voltage to it, then the diode will be entering into the forward bias condition and it will be acting as a closed switch. Now similarly, if you apply a reverse voltage, so in that case the diode will be acting as the open switch. So when the diode will be in the off state, so there will be no connection between this point and this point. So that will be open. Now when it will be acting as a closed switch, there will be a connection between this point and this point. Now, uh, now, uh, now what is going to happen? This V reference, okay, now we'll take this as the plus V reference. So now there are basically here this operation when there is no feedback, or you can say that when this is in the low bias condition, then you will have to compare the voltages. Fine, because there is no connection. No, because in the no bias condition, there will not be any current flow through a diode. So in that case, you will have to compare the input voltages. So this one is the input voltage and this is the V reference. So when you will have to compare, it means that either voltage will be higher than the other. So in the first case, suppose if Vi is greater than the V reference, Vi is greater than the V reference, Vi is connected to the non-inverting side and V reference is connected to the inverting side. So what is going to happen? You are going to have some voltage here. So now this is open condition. So this operational amplifier will be acting in the open loop mode. So we will just mark this as VO dash. Okay, so now what is VO dash? VO dash will be equals to this is the open loop gain of the operational amplifier, this VI minus V reference. Now this open loop gain of the operational amplifier is infinity if you take the ideal op-amp, and for the practical op-amp it is 1 into 10 to the power of 6. Still the value is very large. So this one will be what? This one will be the positive value you are going to get, because this Vi is higher than the V reference and it is multiplied by the very high value of the operational amplifier. So that will be saturated. Fine, that will be saturated. So this one will be saturated. So this one will be plus VCC. Okay, so now V0 will be plus VCC. V0 will be plus VCC. This V0 will be plus VCC. So now this when this plus VCC will be connected here, so what is going to happen to this diode? You can see a positive voltage is connected to the cathode of the diode. So in that case, this one will be open circuited, and when this one will be open circuited, so V0 will be what? So V0 will be I'll draw it again to make you consider, because you can see that plus VCC has appeared here and just a minute, then this one is the condition. The diode is open, this is V0 and this is V in. So what is the output voltage? The output voltage will be V reference only. So output voltage will be V reference only. Fine. So what we will write here, V0 will be equals to V reference. Okay. So now this is the first condition, because when you are comparing two voltages, then first initially we have considered that input voltage is greater than the reference voltage, and in the second condition we will consider Vi is less than V reference. Okay. So now we will try to understand the second condition. Okay, first I will write the output of the first condition, that when Vi is greater than the V reference, then the final output will be plus V reference, and when Vi is less than V reference, then okay, so initially we will calculate the value of V0 dash. So that one will be A into Vi minus V reference. Now this value is smaller as compared to the V reference. So the small mine, this is a negative value. This is a negative value, we can say. That is a small negative value, and when this value will be multiplied by the gain, so obviously that will be saturated. So now this one will be saturated at minus VEE. Fine. So now what will come here? What will come here? I think you are going to get, not I think, you are going to get minus VEE. So minus VE is connected to the cathode, right? When negative voltage is connected to the N-type semiconductor, or you can say that diode will enter into the forward bias condition. So this diode will be entering into the forward bias condition in this case now. Fine. So this is be entering into the forward bias condition. So this diode will be acting as an on switch. So now you can see that this is a special case of the non-inverting amplifier. You can see that this is the voltage follower, right? Because you can see the complete output is taken to the input. Fine. This will be a voltage follower circuit. So in that case, V0 will be equals to VA. Fine. So now when Vi is less than the V reference, the output voltage will be equals to the input voltage. So now you have got the two values. So you can see here, now coming to this waveform. So I think this is the intersection point. This one is the second intersection point. So I will consider as AB. So between 0 to A, what is happening? This input voltage is less than the V reference. This input voltage is less than the V reference. Okay, just a minute. I will just change the color. So this input voltage is less than the V reference. So what is going to happen? What is input voltage is less than the V reference. So V0 will be equals to V in. So I think output voltage will be V in only. So output voltage is going to follow the nature of the input voltage. This is the value. Now between A to B, 0 to A, Vi is less than the V reference. Output voltage will be equals to, this one is V in. So output voltage will be equals to V in. Now between A to B, Vi is greater than V reference. So output voltage will be equals to plus V reference. Okay. So now you can see it doesn't follow the input voltage here. Okay. So again, this Vi has become lower than the V reference. So again, it is going to follow the input voltage. So in this way, you can see that the V reference is higher after point number B. So in that case, your output voltage is going to follow the input voltage. So now after analysis of this thing, you are going to understand that the positive clipper is going to clip the positive portion of the input signal. So in this way, you can create or design a positive clipper. Now similarly, you can go for a negative clipper. So I think I will not go in that much detail because already the concept has been explained to you. Just a minute. Okay, so now this is the positive. You can see the waveform here. You can see this positive portion is clipped off and it is saturated at this V reference. Now similarly for the negative clipper. Now for the negative clipper, what is the difference? We can see the difference is only that the V reference now is taken from the negative supply voltage. Initially it was taken from the positive supply voltage. So now you are going to have the negative value, and negative value means what? This is the input voltage. Input voltage is again taken as the sine wave form, and the minus V reference is plotted in the negative half. Okay, so now again you will have to do the analysis. So initially this diode was in the no bias condition, so you don't treat this as the on or the off. And when this diode is in the no bias condition, so that time the operational amplifier will be operating in the open loop mode. So then you will have to compare the input, these two voltages. So again there will be two conditions, that when Vi is less than this value and when Vi is higher than this value. I think it is clear to you now?